Okay, so for our next three examples here, numbers 4, 5, and 6, we're still using the zero product property to get the solutions for these. So here we go. First one is in a factored state. We have an expression times another expression equals 0. Well, now the expression is x squared. So we ultimately have to solve x squared equals 0. So you have to think, what do I square to get 0? Well, you square 0. If you want to show square rooting both sides, you can. The square root of 0 is 0. But if you're able to see that answer just from asking yourself, what do I square to get 0, and you can jump straight to that answer, please feel free to jump straight to the answer. This step is not necessary for me to see you right. Now, what makes x minus 10 be 0? I think you can see 10 minus 10 is 0. There's your two answers. Done. The next equation has us solve x plus 3 squared equals 0. Well, this is very much like whenever we saw this x squared equals 0. This is basically asking you, what do you square to get 0? You know what you square to get 0 is 0. So now you have to figure out what makes x plus 3 be 0. And I think you can easily see that what makes x plus 3 be 0 is negative 3. Now, one thing I haven't mentioned in any of the videos yet is what solutions to polynomial equations are sometimes referred to as being. Solutions to polynomial equations are very often called roots. So you can be asked to solve this equation, or you can be asked to give the roots of this equation, which is asking you, in essence, the same thing. So the two roots of this equation are x equals 0, x equals 10. What are the roots of this equation? One of them is x equals negative 3. Now, in the event you're getting a solution from a factor that's squared, or a factor that's cubed, or a factor that's raised to the fourth, the solutions you get, the roots you get, are referred to as repeated roots. Now let me explain what I mean by repeated roots. If instead of writing this equation as x plus 3 to quantity squared equals 0, we wrote it as x plus 3 times x plus 3 equals 0, now it looks like one of those ones we saw in the first three examples where we had a quantity times a quantity equals 0, a quantity times a quantity equals 0. What makes that factor be 0 is x equals negative 3. What makes that factor be 0 is x equals negative 3. Notice it's the same thing. You're seeing it twice. It's repeated. So if you have an exponent other than 1, it'll generate a solution, a root, that's called a repeated root. So look here, that factor is squared, so this root of 0 is actually a repeated root also. This is not a repeated root, this is a repeated root. That's a repeated root. We don't have any factors that have exponents other than 1, so this one isn't going to have any repeated roots. You might think, oh, but those are the same. No, they're not. If they had been the same, if this had been 5x minus 7 and 5x minus 7, the solution in essence would be a repeated root because it would have just been written without an exponent, but it could have been. So now let's solve this one. What makes this factor be 0? Well, let me show you how I solve these the fast way. In my mind, I ask myself, what plus 7 is 0? And I know what I add to 7 to get 0 is negative 7. Now, this 5x is negative 7. I need to know, what do I multiply by 5? What do I multiply by 5 to get negative 7? Well, I don't want to end up with a 5. So what I do in my mind is I just put that negative 7 over 5. Because in my mind I can see if I take 5 times anything that's over 5, they're going to cancel out. So whatever it is that I want to add to get 0 for this factor, I cover it up, I say, oh my gosh, it's negative 7, and then I want the 5 to go away, so I put the negative 7 over 5. That's one of my solutions. X is negative 7/5. So let's try that here. What do you take 7 away from to get 0? You take 7 away from 7. Well, what makes that 5 go away? Because now 5 times something has to end up with 7. You want the 5 to go away, so we just put it over 5. There's our other root, our other solution. So So we get those two solutions. Just to use that method a little bit more, I'm going to give you another example of how I do these quickly. But I'm going to do that in another video.